before we jump into the nitty-gritty of what AWS is all about, how we are going to utilize the capabilities of AWS, we need to get certain fundamental things right. And the fundamental things that we need to get right, the use of data, what is data all about, why is it important for companies, and then what are the problems that are associated with this importance? What are the roles that are in the market today that are here to solve those problems and enable data for the organizations to generate value? And then we'll talk a little bit about what cloud's role is in this whole ecosystem and why AWS in specific. And then we are going to talk about what we are going to do as part of this course, the contents of the course itself, and the direction in which I want to take this course. This is the way the slides and the conversations are going to go. To answer the first question of why is data important for companies, it's good that we want to learn what data engineering is, but why is it valuable in the first place? Because importance of data directly translates into the demand for the data roles as well, which is quite an emerging field nowadays. So this is a list of things that data could potentially add value to the company's in. And the first thing is the informed decision making, meaning that data driven decisions or insight driven decisions can lead you towards a path that could generate better profit margins than based on anecdotal evidence or blind values instead of what the facts are. Certain leadership teams in certain organizations fail to adapt to such technologies. Like there might be multiple examples in the market today. Companies like Nokia, why they were not able to withstand the competition in the market. All of that is because of the lack of trust in technology as well as data to a certain point where if the insights are telling you to go in one direction, but your gut, so-called gut feeling tells you to move in a different direction, you end up not sustaining in the market. So insight-driven decisions are something that you need to look out for in today's business organizations, and data helps you do that. One of the examples of this is forecasting, for example. What is forecasting? Does anybody know what forecasting means? It is to analyze the trends of the data and then forecast those trends to the future. And then today we can take insight driven decisions based on the future trends and place ourselves in a risk averse situation. That is something that an informed decision making process can get you. And data is the fuel for this process, enhancing customer experience. So, how many of you guys would have this would have happened to all of you? If you search for something in Google, you would see ads pertaining to that in any of your social media platform. So it's a pretty common occurrence. There is no need of asking whether you have experienced this or not because you might have already. So, how is that happening? It is because your cookies or your data is being mined by these companies and they are selling it to third party people who are understanding the customer behavior. And companies like Amazon are generating personalized recommendations for you. Why is this happening? This is happening to increase the probability of your interaction with them. And by when I say interaction, I mean monetary interaction, maximizing the probability of you spending money by targeting you and giving you the exact ads to the products that you will need in that particular point in your life because you searched for it already. Now, data helps such organizations do that. And that is an additional revenue for the company, right? It looks better in your company's profit and loss statement. Operational efficiency. Here is an example for something like this. Let's say that you guys are working in a production support team, and as part of that production support team, your job is to take care of a particular tool or a technology that you have hosted in your production environment and solve all the issues or access related tickets that come along with. Now, let's assume that you guys don't talk to each other because you're geographically spread across different locations because you're a 24-hour support team. So let's assume in this example, you're spread from India to UK to US, three countries overlapping and covering 24 hours. Now, there is a bug that keeps happening or a ticket that keeps coming up. Let's say an access related ticket where you need to provide access to a specific feature of that particular application that you're supporting to some clients. Now, because you're geographically dispersed in multiple locations, you guys are working on the same thing over and over again. You keep getting access requests and you keep finishing those access requests. And you as a team have invested about 30 hours in 1 month just to do this particular task. and nobody knows and nobody is looking at the data behind the ticket. So let's say somebody comes and looks at all the tickets historically in the last 2 years and finds out that simple query in our world of data engineering, find me the repetitive keywords, the top keywords that are repeated. And it's so obvious that access related tickets is something that you as a team are solving across the globe. What do? You spend time in creating documentation and make it a self-serving capability to the consumer and automate that whole approval process as well if it is an access control thing. And now your team is 30 hours, 30 hours of man hours free for doing something else like a continuous improvement to improve some other process. As a result, you are saving time of your resources and making their time much more efficient than it was before. That is what streamlining a process is. And you could allocate your resources in a much efficient way, and data analysis can help you do that. And again, the fuel for this analysis is data. You're seeing, right? Everywhere we go, it is either going to be a saving of money or adding new streams for money. Competitive advantage, you're entering into a let's say you're a retail organization, you're entering into a market. You've done some analysis about who are the market competitors before you enter, and you have decided what your pricing strategy is going to be to undercut your competition to make sure that your new venture into the market isn't a disaster. How can you do that? You can buy data from third-party companies like McKinsey, analyze the data, do your market research, fit your pricing strategy, get into the market and execute them, and at least compete with your market competitors. Then you becoming their prey. As a result, you innovate your ideas and you go to the market with those innovative ideas, and data helps you do that by collecting the right market intelligence. Revenue growth, as I said before, the way personalization works is that you as a customer, not just in personalization, but in anywhere where somebody is doing customer analytics, you as a customer will be put into a certain segment. And depending on your interaction and people who have interacted like you with the organization. Now, if these segments are targeted for campaigns like emails and SMSs or promotions or offers, and that enables you as an organization to upsell or cross sell to your customers. Can anybody guesstimate what upselling or cross selling is when it pertains to revenue growth? What does it mean? Upselling and cross selling means upselling is sell more of the same product, cross selling is sell more of similar kinds of products. Targeted marketing can help you do that. One advantage of that is you're not overly dependent on one particular product. You diversify your sales across different brands to make sure that you don't create a performance bottleneck for yourself as an organization through cross selling, and that adds revenue as well as diverts some risk for you. Data can help you do that. Why are we as a data engineers here? It is to empower businesses to do all these activities through their analytics and data science teams. And without a data engineer being able to enable these capabilities of data, nobody will be able to derive value from it. And that is where we are going to fit ourselves into and learn about all the other AWS services. What is risk management? Like a financial industry, credit card fraud. If you are able to predict that this particular account is going to default ahead of time, you can take some mitigation activities to make sure that it doesn't create a revenue loss for your company, for your bank. That is something that data can help you do that by studying past defaulters and what the patterns in data are. Data as a revenue stream, this is something up and coming now, where you as an organization can whitewash your data, meaning clean the data to make sure that none of your specific company's attributes or your company's customers' attributes are present, like sales transactional data, what kind of products in what geographical locations and what amount of sales. These kind of things you can have in the data, but which card did the customer use to pay? What is the name of the customer on the card? Which store in your particular organization did the transaction? These kind of things you'll whitewash over. And you'll sell this whitewashed data or cleaned data or anonymous data to a company again like McKinsey, who will then sell this data to other people who can do market intelligence analytics for you, gaining competitive knowledge as well. And you as a company are additionally generating new revenue streams by monetizing the data and selling it. This is also something data can help you do. Regulatory compliances, when you are in healthcare, for example, and healthcare insurance, you are expected by the government of the country that you are operating in to retain data for certain period of time. You have to follow that regulatory compliance. You should store data in a particular location. You have to follow that regulatory compliance. How many of you guys know recently in the last 6 months, company Mastercard got kicked out of India to do businesses because they failed to follow our country's regulatory compliance by storing Indian related specific data on a different country's server. Now, this is not something that they should have done, but as a result, they got booted out of the one of the world's fastest growing markets to do businesses. So that's something that they lost, and Visa overtook them. That is something that will topple the company's foundation, but just because they did not follow particular regulatory compliance. What your data can do for you is to make sure that your regulatory compliances are met, your risk assessment profile is done on those regulatory compliances, and you are transparently showcasing that to the stakeholders. As a result, you'll build trust in the company. Now imagine this and a different set of example that you as a CEO of a company are pitching to the stakeholders the current quarter's performance and the direction in the next quarter is going to go. Now, there is no single source of truth in your organization. One team, even though the data is being originated from same data sources, its interpretation is different from different teams. And you as a CEO, right before the stakeholder meeting, get fed two different numbers for the same exact quarter's performance, and you make a choice in real time on which to data to present to the stakeholders, and turns out that that's false. Now, what happens at the end of a stakeholder meeting? Stakeholders tend to set the share prices of the organization to steer their business in a risk averse situation. Now, if that pricing is based on wrong data that the CEO has presented because of same source but different interpretations, the trust of the customers who are your shareholders will be eroded as a company and you will perform badly. This is a good example of a publicly trading company that could have a downfall because you are not building trust. Now, data could help you do that if you have done your governance policies right as part of the data engineering team in your organization. You will never have such a scenario where the source is same and results are different. We'll talk about all of this as we go further and which services can help us achieve all these kinds of capabilities. But I hope this makes sense to you that data is important for why data is important for companies. A few real world examples which leverage data in real time and gain some value out of it. Small examples, nothing fancy. Like Amazon, as I said, uses personalized product recommendations. You might have heard of Great Indian Sale or any other sale in a different country. How do they come up with those promotions of those particular products, which they are targeting certain customers to do upselling and cross selling? That's what Amazon does by its data analytics and personalization strategies. Netflix leverages the viewer's data to tailor make the recommendations for you so that you will keep engaged on their platform. So you might have realized that the Netflix has a certain capability to keep you hooked on it because the recommendations are much better than other streaming platforms. But that would be the capability of an analytics team. Now, in the same Netflix ecosystem, can I talk about how, if you notice this, even on a 4G signal, you can stream at least 1080p movies on Netflix, while the same network strength is not enough for Netflix, other streaming platforms to stream movies to you, like other streaming platforms like Disney or Prime Video. Have you guys ever experienced that even in lower network bandwidth, Netflix is able to deliver content to you? And you would be surprised to believe that Netflix's end-to-end architecture is built in AWS, as well as their data engineering team have done amazing job in making that network latency and throughput better for you. That is the biggest thing that you can talk about Netflix as an achievement on the data engineering side. Data analytics side, yeah, they're making sure that they give you tailor-made and recommendations and keep you engaged. But on the engineering side, you would have noticed the performance of Netflix in terms of lower bandwidth in your network when compared to other providers. If not, then give it a try and see the difference. It could even be as small as audio. This is not an ad for Netflix, guys. I'm just telling you that the audio quality could also have a lot of difference. And that is the marvel of the engineering team that has put in all this effort and the capabilities of AWS that are completely showcased. Tesla uses real-time vehicle streaming data to do autonomous driving and make sure that all the data is analyzed for future customers as well. And they push data to do on-air updates, on-air software updates, and AWS can help you do these kind of pushes as well, like how Google and iOS, Apple do their software pushes to your mobile to upgrade your operating system. Similarly, a few fun facts about the data that is an ever-emerging market is 90% of the world's data is generated in the last 2 years. Let's sit with that fact for a minute, and can any one of you say what that means? What does that mean? If 90% of the world's data was generated in the last 2 years, if you choose to be in the world of data, are you going to make sure that are you going to have ample opportunities to grow? That means that the world of data has ample amount of opportunities, and it is also relatively future proof. That is the most important thing that you guys need to understand, that when you step into the world of data, it is not just that there are lots of opportunities, but these opportunities are going to outlast a lot of roles that are currently going to become obsolete. This is the right step in the right direction, is the point I was trying to make. Whatever you guys are doing, of course, you have to put your blood, sweat, and tears. Nothing good comes easy, and you'd have to work hard to penetrate into the field, and you have to learn a lot as well, but it'll all be worth it at the end. That's the point I was trying to make. So by 2025, the global data sphere is expected to grow to a size of 181 billion terabytes. And self-explanatory, I've also included the sources so that you guys can go and search for it yourself. I don't even want to comprehend what that number means, 181 billion terabytes. So 92% of global companies say that data-driven decisions are critical for their business growth, and that's a good thing because that means that you are not basing your business decision makings on certain anecdotal knowledges or evidences, but it's hard data-driven decision. Uh, Real-time data analytics, real-time data streaming is also a very important aspect that we're going to learn in this class. Not just batch streaming, batch loading, but also real-time streaming, and that apparently saves $1.2 trillion in terms of operational efficiency. But this is only based on operational efficiency. That number would be much more higher when you consider all other facets in which data saves money by adding extra revenue streams, by improving your current profit and loss statement, by minimizing the loss and keeping the profit as it is. These are all the things that data can do for you. 53% of companies are using real-time data to make critical business decisions, meaning that when you learn what you're going to get out of this course, you're not only going to get the batch loading process, but you're also going to get the real-time streaming capabilities as well. You're going to simulate real-time data, and we are going to build AWS infrastructure to stream the data into any database or any storage service and make informed decisions on analyzing that data. The Now, because the data is growing so rapidly, what are a few challenges that are going to follow because of this growth? Managing scalability and performance with rapidly expanding data volumes. When the size of the data grows, you'd also have to scale the storage. You'd also have to scale the compute. Storage is directly related to the scalability of the data, and compute is directly related to the performance of the data. Performance meaning more amount of data, and if you are looking for real-time data-driven decisions, more amount of compute will be needed. Ensuring data accuracy, consistency, and reliability to make sure that customer trust is not eroded and stakeholder trust is not eroded, and you're making informed decisions on data and not uninformed or misinterpreted decisions based on data. Because in the world of data science, there is a saying garbage in, garbage out. You would have heard of this. Now, if the data quality is garbage that you are inputting into the machine learning model, it will generate garbage predictions as well. And as a result, when you make actions based on those predictions, you might end up screwing your business more than helping. As a result, you should maintain data accuracy, consistency, and reliability. Addressing stringent data security and privacy regulations. Again, compliance is a very big aspect. Security of the data is a very big aspect. Personally identifiable information cannot be exposed. Ethical use of data is a very important aspect. And as the size of the data grow, this becomes that much more challenging because more questions are going to arise on how to manage this stuff. One as another aspect is as the number amount of data increases, it is also you can also think that synonymously the platforms or the sources of data are also getting diversified, right? There are more uh, data sources. Which one could be an API, one could be an SQL Server database system, another could be another cloud service generating data for you, another could be a custom application that you have developed as part of your organization's capabilities. It could be anything. It could be a till from the stores of your organization, where the transactions happen, the POS machines. It could be anywhere. What is the challenge? You would have to integrate all these platforms which originate data in different formats, and some of them could be legacy systems, into a unified platform and provide capabilities on top of the platform to your organization, balancing cost effectiveness while maintaining high performance systems. Now, as nobody works with an unlimited budget, as the data size increases and you still need to meet your SLAs in terms of meeting the demand, you have to also make sure that you make cost effective decisions while keeping the performance good. That is something that you need to take care of. When you talk about specifically real time data challenges like latency and throughput or anomaly detection, as the size of the data increases, the computation is also going to get intensive. Then the latency and throughput are specifically bottlenecks for real-time data streaming. Now, with all these challenges that you have to solve for, these are the roles that are going to help solve each of these challenges. And we are going to talk about some of these roles and what they are supposed to do in an organization. Data scientists, data engineers. Does anybody know if does anybody have any questions on what these roles are, if they have not come across these roles or what their responsibilities are? If something seems forget about the emerging roles that's happening now. It will take some time before they get formalized, but the ones above scientists, engineers, analysts, architects, ML engineers, developers, do you guys have any doubts in what their roles and responsibilities are? We'll talk a little bit about what data engineers are. They are the data enablers for the organization. In the next classes, we'll talk a little bit about data mesh architecture, where you will see a version of these enabling capabilities that a data engineering team could have. But by default, these are the people who build scalable pipelines to move and process data efficiently from point A to point B. And they also optimize the storage solutions that any kind of data can have. If you're dealing with a data warehouse, you might be looking at structured data with foreign primary key relationships in Snowflake or Star Schema, and powering up some operational dashboards or the ad hoc analytics. If you are looking at a data lake concept, you'd be supporting unstructured data, structured data in all formats, and you can then disintegrate this data into meaningful tables and power up certain use cases like machine learning or analytics. Either way, what is the kind of storage that depends on what your organizational capabilities are as well as future aspirations are, and you have to manage and optimize the storage for your organization. So you can also work on enabling real-time data access for analytics and decision making, making the dashboards real-time or get refreshed every 15 minutes. I would say that is as near real-time. Real-time is in milliseconds. Basically, the data engineers play a role in bridging raw data with actionable insights. That is the biggest and the most important way in which that is the biggest contribution of what a data engineer is supposed to do, and the most important lens through which you can disintegrate the responsibilities of a data engineer. What could a data scientist be doing? Keeping the world of data engineering aside, they could be applying advanced statistical methods to uncover data trends. It could be like a time series analysis that could forecast what the sales are going to be in the next quarter. As a result, you set budget for those sales across your stores, and you ask those stores to meet the budgets by making them performant and giving them what are budgets. Budgets are sales targets basically that stores have to meet. You can forecast the sales based on history. You can provide these sales as inputs to the stores and set a budget for them and give that budget as a target that they have to meet to be profitable. And if they miss their targets, You make some cost cutting activity. If those targets are exceeded, you make sure that you add more resources to the store because there is market demand in that area. These are all the things that you could do. As a small example of what statistical methods could provide, that data scientist role can do these kind of analysis. You can build machine learning models for prediction and automation. Any use case that you can think of, even customer segmentation, that this customer belongs to this particular bin. As a result, you target them in this way and you can upsell your product. Work on feature engineering and algorithm optimization. Another aspect that is a very important responsibility of a data scientist. You get access to the raw data. Data engineer will enable you after they're clean, transformed, and assured the quality of the data. They will give that information to data scientists and they will do feature engineering on it, basically aggregating and disintegrating columns in the tables as per the domain knowledge that they're operating on. And they also have to hyperparameter tune the algorithm to optimize its performance as well as its cost, infrastructure cost, while keeping the processing time to a minimum. And then once your machine learning models are ready, you can collaborate with ML ops engineers or data engineers in certain organizations where ML engineering is not a thing, to enable operational architecture for machine learning models, productionizing machine learning models, basically. That's also something that as a data scientist you could be doing. Data analyst, mainly using visualization tools to create Power BI dashboards or Tableau dashboards, interpret complex data into actionable insights for stakeholders. These people mainly do ad hoc data analytics. They're specifically looking for something that they want to go after, and once they get their answer, they'll move on to the next analysis. There is no machine learning kind of capabilities involved in this role. They only do these ad hoc analytics based on the current requirements of what a business is. A good example of that could be that you as an organization are trying to buy another company, and you don't know what the profitability of that company is. You don't know what price you have to offer to buy that company, while making sure that you will not go into a loss if you buy that by overpricing it. How does that work? Who will be able to give this information to the business? They will give a data analyst the job to dig through the data of the company, and they will expect the data analyst to come up with the answers about risk assessment of what pricing they could offer to acquire that company. These are the kind of things that this is again an ad hoc activity, right? You don't buy companies every day. You don't need a machine learning model for it. If you have just started doing it, if you are in the business of buying and selling companies, that's a different niche altogether. But if it is an ad hoc thing, data analysts are the people who will do this. They're also the people who build and maintain KPIs and highly performant Power BI dashboards. KPIs are key primary indicators of where the direction of business is going. It could depend on the domain again. Healthcare could have certain KPIs. Finance sector could have certain KPIs. It highly depends on what domain you're operating. Retail, for example, one of a major KPI could be profitability per order. Let's assume that this is one KPI. Profitability per order, order basket size, two KPIs. These two things you will be tracking. Data analyst would define what the definition of that KPI is, what measures to be included, what is the formula, and they will build a Power BI dashboard to do that. And you as a data engineer will enable and empower data to the Power BI dashboard in the format in which the data analyst has asked you to give them. Collaborating with business teams to understand their data needs again, and then giving it back to the data engineer to build those capabilities. Now let's go and understand the role of a data engineer one level deeper. This is mainly to design and build ETL pipelines. Now, how many of you know what ETL means? You've heard it from a person who has live experience in what the one level deeper important role of a data engineer is. When you design and build ETL pipelines, as an extension, you also have to manage the data storage where the pipeline is dumping and loading the data. If it is still in your company's ecosystem, you'd be modeling the data as well. For certain use cases for Power BI, you might be creating certain aggregation layers on top of fact dimension tables, for example, that you're building. You would be creating some feature engineering tables on top of the existing data. You'd be modeling these feature engineering tables for a certain analytics or machine learning use case. That is also something that you would be doing, or you would be expected to do. Integration is again when as a challenge of ever growing data sets, the data sources can also be so diverse that you work on integrating all of them into a common platform, and all of this while ensuring the quality of the data and following the security and compliance of it, and making sure that it is cost effective optimizing the queries and the pipelines and the infrastructure scalability at the same time. The fundamental activity that you as a data engineer would be building is the capability of extracting, transforming, and loading the data, or in certain cases, extracting, loading, and then transforming the data. But the extended responsibilities of doing this activity is to set up enough monitoring mechanism to make sure that if a pipeline fails, you'll be proactive in reacting to it. You'd be managing the storage, you'd be managing the diverse data sources that are generating raw data for you, all while you're assuring the quality and compliance of the data, which might be a part of your data governance charter in your organization, and making sure that all of these run in an optimized manner to save money. And you're getting the best bang of the buck you are putting into a cloud capability or a warehousing capability. Either way, this is what the role of a data engineer is when you go one level deeper. And you're going to see how AWS as a cloud provider can empower us to do our job as a data engineer, which are these things. So, why a data engineer? First of all, the job demand is not going to go anywhere. If anything, the growth of data is even more rapid and is going to get rapid. 50% year-on-year growth is a crazy number to begin with, but I'm assuming that it would be even higher. Like I've seen recently in LinkedIn, there was a 6% growth in the role of a senior data engineer. Only for senior data engineer, there's a 6% year-over-year growth. Now, the role of a data engineer is highly in demand mainly because these people encapsulate the most amount of activities within a data lifecycle. And we'll talk about what the data lifecycle of an organization is, but that is the reason why the demand of this job is not going to go anywhere. There will be a number one in hiring priority. You as an organization, it's not enough that you have data, you also need to have it in a usable format. And data engineers are the people who will do that for you. That is the reason why it is in the number one hiring priority, as well as the industry adopting it. This is not a fad anymore that the world of data is growing role. No, 90% of the companies of Fortune 500 who are cutthroat in the capitalistic markets that they operate in are adopting this role. 90% of the companies of Fortune 500 adopting a certain trend means that the trend is here to stay. And you can check the sources as well at your own free time because you'll get access to this video recording. I've included the sources. The future projections are 31% growth by 2030, and I think that is conservative in nature. It is going to be even more rampant. It is going to be much higher than 31%. The reason is because the amount of data that is getting generated and the amount of insights that are being generated and the amount of money that is being saved by organizations, it cannot go back. It has to be only in one direction, that is up. Now, keeping that aside, what is the data lifecycle? Typical data lifecycle in an organization look like? Generation of data. Data is created or acquired from various sources, and it is extracted, and it is into a single platform. It is processed, transformed. It is stored based on what technologies you as an organization are subscribed to. You manage access to the data, you manage the data until that point where your data generation might be out of our hands because it could be coming from anywhere. The collection, the processing, the storage, the management of the data is in the hands of a data engineer. The analysis of the data could be in the hands of a data engineer. In certain cases, in certain cases, a data engineer. In certain cases, a data scientist and data analyst. The visualization is almost always going to be in the hands of a data analyst, and the interpretation or machine learning models or algorithms are going to be in the hand of a data scientist. Now, if you see, there are 8 steps, right? 50% of the step, data engineer is responsible for in an organization. You can't automate your way out of it, no matter how good these ML algorithms are. You can't automate your way out of managing all this stuff while making cost effective decisions. Why you can't trust an AI algorithm to manage personally identifiable information for you. You can't uh, you can't give them domain knowledge in understanding in what kind of system do they need to be stored, because you understand that these could potentially be leveraged in these use cases in the future. So this is the reason why I said that it is the number one thing in demand, as well as it is future proof from any sort of risk. And there is also a very important saying that a good data engineer could become an amazing data scientist, but it doesn't work the other way around. Only because if you start as a data engineer, there is a role in Java development called full stack developer, right? Similarly, if you start as a data engineer and work your way towards analytics and data scientist, you could become a full stack data developer as well. And data engineering is the best place to start because you will learn 50% of the data lifecycle already by the time you exit this role and enter into the next part of your journey. Now, why cloud? First of all, we have spoken about data, we have spoken about data engineers, we've spoken about how organizations are leveraging the capabilities of data. But why cloud? What is the role of cloud in all of this? Cloud is the way you do the lifecycle activities, the meaning, the storing, the management, the analysis, and the way you leverage the capabilities of cloud to integrate data from multiple sources. And all of this while you are following regulatory compliances, it is flexible enough to give you cost optimized solutions. We'll look at how. Uh, while it is also anticipating scalability, meaning the growth of data requirement for your organization. So, in my own way, I think if data is the food we consume, cloud is the Akshay Path. So, do you, in your mind, think that it is the food that is generating itself, or the infrastructure or the bowl that is doing that activity? In my view, it is a little bit of both. Akshay Patra meaning the bowl in which we have unlimited food is the cloud itself. Cloud will give you the capabilities and infrastructure to scale your data innovation and data development and data driven decision making capabilities in your organization. It will help you reach where you need to go, all while making sure that these governance related activities are met. That is the power of what a cloud can offer you. Now, an extension of the same conversation is it's your all in one stop for data storage, the data processing and analytics integration while maintaining cost, while following security and compliance, while you provide accessibility and collaboration. So there are a lot of Fortune 500 US companies that are operating in India, guys. How are they able to follow regulatory compliance but still provide analytical roles in India for analyzing the data? It is because cloud gives them the capability to follow regulatory compliance by storing data in their country while providing controlled access to people who are outside their country and still get benefits out of the same. Cloud is giving you the flexibility to empower yourself with this kind of ecosystem as well. And as a result, your innovation will become that much faster. Your time to value will become that much quicker. Now, AWS, there are multiple cloud providers in the market, definitely for sure. But what is the advantage of learning AWS first? First thing is, it is the market leader, as in that it has captured the most amount of market share. It is ever moving percentage. I think it's in north of 40% or something about now. It also has a first mover advantage because it came first in 2006 and it faced a lot of issues that it already solved for, which the relatively newer cloud providers are still going through. But one other advantage, because it's a first mover, is that there is a lot of support system that comes with it. There's a lot of support documentation, there's a lot of knowledge that is out there that can be leveraged by you to become an effective data engineer because many people have already gone through these journeys and they would have given you a solutions and like Stack Overflow, but for AWS. Think of it like that. So you'll also have that support group, which is much diverse and much more comprehensive compared to other cloud providers. So their strengths are scalability and global presence. I think it's over around 200 locations, but they are ever increasing. That's why I did not include the exact numbers because if 2 days later, if they have 201, someone will come and ask you told 200 only. So that's the reason why it is scalable. It is globally present and it has a comprehensive offering for compute storage and as well as machine learning capabilities. I hope at least a few of you would have seen or attended the reInvent event that AWS has done recently in December in Vegas. If you there are slides and open source material available for you online. You guys take a look at that. You will see which direction them as a cloud provider are now going into. They're going into quantum computing and they're going into enhanced LLM capabilities or machine learning capabilities, advanced analytics capabilities, and building those services. So it is flexible that it's good enough for startups as well as enterprises. and it is cost effective and gives you a lot of options on the table, and its UI UX is quite intuitive for you to understand how things are. It, instead of it being very intimidating, almost all the details are present on the services for you. You just need to know certain caveats on how to leverage them in a cost effective way, which we will be learning as part of this course. But then, nonetheless, you have the capability to go in, log in, and explore yourself as well, and come up with any questions in case you guys choose to attend the future classes. Now, why this course? The answer to that question is that me, as a data professional with just about a decade of experience, have my master's in data science and have implemented end-to-end analytical and engineering solutions. We will be doing this course in a hands-on manner, and we will be building our own CI/CD architecture as part of this course, meaning that you will not be creating resources in AWS through its console. You will be throwing it programmatically from your desktop. And as a result, you would need to have your own GitHub account, your AWS account. And we are going to build this architecture locally first as part of our development ready kit. And then we are going to go into learning about these services, their capabilities, and then deploying these services into AWS cloud programmatically. Now, if you guys are in touch with what the real world data engineering expectations are, you are expected to know cloud for sure. You are expected to know warehousing like Snowflake or Databricks, that's fine. But what they don't tell you is you also are expected to know what CI/CD is. Do you guys know what CI/CD means? Any organization, any mature business organization, for the reasons of security, will not allow you to create resources in cloud through its user interface. You, when you open your own AWS account, you can't go and create an S3 bucket if it is an organizational account. You can do it in your own free tier account, yes, but you will not be allowed to do that in your organization because there is no audit to that. Who some anybody can come and create any bucket, as well as there is no compliance or security related this one risk to it. There is a compliance or security related risk to it. So they wouldn't want anybody and everybody to do their deployment. They will be controlling it through some intermediary service. In our AWS case, it's called Cloud Formation, and there will be intermediary services like Jenkins or GitHub Actions, which will interpret the code you write. It could be in YAML scripting, it could be in Terraform. Then it will interpret the code you write and it will deploy those resources onto cloud. So everything we do as a hands-on activity in UI in this course, I will also be providing you with code that you could upload to your own GitHub account. If not, you should be creating one. You don't have it, and you'll be deploying it through program as well. And I'm not sure how many of you have AWS accounts and GitHub accounts. Um, so before we talk about who has and who hasn't, we will be covering the course in this comprehensive manner. And this course overview is just a direction for us to go in. We will be learning every and any service in AWS for sure, and we will be trying to build real-time and batch ETL pipelines as part of this. But it will also be fluid in nature. It will also be adaptable in nature in case you guys need me to spend some amount of extra time on a specific service because it might be useful for you as in your learning activity or in your organization. We will take the time to make it happen.